All right, this is a decidedly not technical talk. Hello, everyone. My name is Jeffrey Young. I'm coming to you from IOG. I work on GHC full-time for IOG at the DevX team with Sylvan and Laita and Josh. Okay, so I want you to recall the time you first tried to optimize a Haskell program. And unless you're Joachim or Simon Marlowe, what did you do? How did you learn to optimize a Haskell program, or what did you even look for? And was that experience fun? Did you have a good time? Was it easy? Or were you just swimming down a rabbit hole of Google and trying to, or maybe even just grepping through source code looking for notes? Let's say you went through Google. Perhaps, if you're like me, you first checked Joachim's blog, and hopefully it was after 2019, and he had published his Faster Haskell Winter series, which if you haven't read it, I highly recommend. Or then maybe you went over to Mark Karpov's blog post and looked at how he optimized megaparsec, which also is a very good blog post if you haven't read it. And then finally, maybe you're in more modern times and you're using GHC9 and you think you have a memory leak, and so you go over to Matt Pickering's blog post and you try to use event log to see what the heap is doing. And then you think, well, lots of companies use Haskell. They all have engineering blogs, so I'll check FP Complete's profiling performance blog post on how they did some optimization. And well, if you've checked FP Complete, well, you have to check well-typed, right? And I don't think Zubin's here, but props to Zubin for making HLS much faster. This also was just released this year. But yeah, so then if you've checked well-typed's blog post, well, I mean, you cannot forget Twig, right? And I don't think Facundo's here, but props to Facundo for publishing this just last month. And I also had to throw my own blog post up there because, when you have the time. Okay, but then, these are all just blog posts on the internet. And you know that there's lots of Haskell that happens on GitHub. And perhaps you've heard from Twitter or a certain Orange website that Alexis King is very good at having nice and precise clear, concise explanation. So then you go searching on GitHub, and sure enough, not only is there legendary comments by Alexis on when to use fold-L or fold-R, but there's also an Orange website thread arguing about it. Lucky you. And then maybe you have my preferred method, which is you just get a big cup of coffee, you look at a library that you think is reasonably fast, and you read through some code and see what techniques they have and hope to God that they've commented on them. So all this is to say that, we have the technology. The information is out there, right? You want to optimize your Haskell programs. You can find the knowledge if you look reasonably hard or have enough time. But it's diverse, right? It's spread all over the place. It's not consolidated in a single place. And I think this has several knock-on effects. So one is I think it raises the barrier of entry for Haskell in industry. So if I'm a project manager and I'm trying to choose a tech stack, why would I choose a language where it looks like the optimization story is relatively good but hard to understand, hard to learn about, right? I think this also propagates the idea that Haskell is a hard language, in quotes, to optimize. It's very fast, but I think it's if you don't know how to optimize it and it's hard to get that information, then you start constructing this sort of idea. The last knock-on effect, I think, is that it leads to proof-of-concept libraries that proliferate in the ecosystem. There's nothing wrong with proof-of-concept libraries. There's lots of nice PhD thesis implementations on Hackage that have no users. But if you are trying to run a company on Haskell and you know that there's a solution on Hackage and you pull that package in, you hope to God that they have done the last step of productization on that package and optimized it so that it's useful in a product scenario. Okay, so what's the solution? So this is the subject of the talk. It's the Haskell Optimization Handbook. This was the purpose of the Haskell Foundation Tech Proposal number 26, which was accepted last year. And I want to drive home the point that I've identified, I think, a social problem, and I want to just say, as a community, we can just choose to fix this. And, hint, hint, choose meaning, please donate your free time and labor to me. Yeah. Okay, so what is the Haskell Optimization Handbook? It's a handbook, first and foremost. What I mean by that is It does not have a long section on why you should use static strong types. It's not going to be talking any kind of philosophy to you. It's simply brass tacks. You have a problem. Here's some solutions. Please look it up and try to fix it. It should always be freely available. It should be in the common domain. And I want it to be actionable. You should be able to go to the handbook with a problem, read a chapter in the handbook, and immediately apply that technique to your code base. It should be relevant. So the case studies in the handbook should come from real experience. They should not be toy examples, although if we don't have a good example, a toy example is better than none. And it should be practical. For any technique in the optimization handbook, TOW, when it should tell you when should you use TOW, how to implement TOW in your code base, how to observe the effect of TOW. Okay, so we can have a look at it, and hopefully I know how to manage a computer well enough. Aha, I have to Google. And IOHK handbook, Haskell Optimization. Oh, gets me every time. Okay. This is the GitHub repo. We'll talk more about that in a few slides. Okay, so this is our splash page. And I really want to focus on the table of contents. Everyone can see this. Is the font big enough? Should I increase it? Okay, so there's three major sections. The first one's preliminaries. We're not going to talk about that. The second one is measurement, profiling, optimization. And all I'm really trying to do is I'm trying to just have a list of things, a list of techniques that describe how to measure, profile, and observe what your Haskell code is doing. I learned about a new one of these this morning, the profiler and the embedded DSL talk. Okay, and then the ordering of these should be least invasive to most invasive. So you see things like just GHC-based techniques, third-party methods like using cache grind. That was the blog post, the Twig blog post I showed earlier. CPU cycle measurement, doing tickyticky profiling, using third-party bases for CPU measurement, like using perf, valgrind, visualizing with flame graphs. All of this information exists. None of it's new, but it's not in one place. And then part 3 is really the meat of the book. It's optimization. So perhaps you want to tweak the runtime system and garbage collector using some GHC flags. Then you might think, oh, I can choose better data structures. What library should I use for that? All the way to, when to use GHCX, specialization, fusion rules, unboxing, or down to the downright insane, like, I say insane, but I hope it becomes less insane, like using levity polymorphism to control the runtime representation of your data types, or using backpack to unroll your data structures, but that one's only for the brave. And you might think, oh, this looks very, very comprehensive, Jeff. Good job. I also want to point out, I wanted a section on direct observation, so reading core and reading SDG. And when I talk about reading core, I mean reading core with no flags to remove the information that comes when you just dump core. I want to know about what the occurrence analyzer is doing and all that nice stuff, because yes, that's going to be a very long section. It's not written or even started yet, but all of the information on reading core always removes that information. Yet if you look at what GHC developers do to optimize, they read that information, connect it to a subsystem in GHC, and then make a change. So anyway, back to this being a very nice list of things. We'll click on one. Oh, it's not there. And it's not there because basically none of this is done. I've written the preliminaries. And that leads me back to the presentation. So this talk is a cry for help. Please help. Please help write this book. And here's how you can help. You can be a writer or an editor. So lots of the topics in the book say using levity polymorphism. You might not know much about that, but thankfully Richard has published, I think, 2 videos on YouTube describing exactly how to use that to speed up a toy program. And that's a great contribution to make, because you can first get approval from Richard to take that material, then watch the videos, and then write the chapter for it, and then add it to the book. So you can write, you can edit, because when we have things that people have written, we will all need to review them and edit them. And let's see. Yes. How can you contribute? So let's say you want to contribute. We go back. So the real value added of the Haskell Foundation proposal was not the concept of the book. It was setting up a social machine, basically, to have contributions that don't get stuck. So say you want to contribute. The project is all in GitHub. Every chapter is represented as an issue. So if you go to the issue list, you see all these chapters. Some of them have auxiliary information for you to help you get started. And what you'll do is you'll go to the project, pick an issue, put it to the in progress section of the Kanban. And I have all this written down in a contribution document. And then someone will be assigned as an editor. Then once you're done, it goes into needs review, and then you can review. So if you're interested, please go to the GitHub repo and start reading the contribution and working conventions links. Okay. And last but not least, yes, this is my last major point, and then I'm at the end of my slide. And I really want to highlight it, but we need non-experts. I want people that do not work on GHC, have not presented at ICFP. I want these student volunteers that are walking around. I want people that have just started using Haskell in like the last year, right? They don't know about Cobble Hell. They're children of summer or something like that. And I want these people because the book has to be communicative, right? This is all about propagating information that GHC developers and, of course, hardcore group of people have. And we want to make that information accessible to lower barriers of entry. That only happens if we can write in an accessible way. And the best check on if the book is written in an accessible way is to get people who are non-experts to read it and say, I don't understand X, Y, and Z, right? And that's part of the review and editing process. So if you think you don't know anything, you're the person to start contributing to this book right now. And with that, I'll end my talk. Please like, star, comment, tweet, yell at me on Twitter, star the book, popularize it. I would like this to be a success. I hope you do too. All right. Thank you.